Hey guys, welcome back. In this particular video, we're going to be taking a look at traffic that is destined to the firewall. How do I control that? In the previous video, we explicitly talked about allowing traffic through the firewall. So what if I want to control traffic to the firewall? Let me show you what we had done prior to this and see what this particular module will teach you. So if you remember our topology from the last time around, I still have it over here. Same topology that I've been using for these labs at this time. So I have this topology, I put an ACL, I applied that ACL over here to my outside interface. It was called outside from the previous video. And in there I permitted a bunch of statements. And just like a router ACL, it would have an implicit deny IP any to block all other traffic. All right. So now if I go in onto router 2 and try to ping the ASA firewall, which is not allowed in that ACL, you can see that over here. If I go to the ASA firewall over here, show run access dash list, I have all these permit statements permitting this, permitting that, and then the implicit deny any. Although there's no mention of router 2 being able to ping 192.1.20.10, which is the outside interface of the firewall. Let me show you that. 192.1.20.10, I can still ping it. The reason I can ping it is because the ACL does not govern or affect traffic that is destined to the firewall. This is to the firewall because it's destined to an interface on the firewall, the same side interface. So how do I control that? That's what the gist of this particular video is all about. So in this particular video, we'll take a look at what do you define as traffic destined to the firewall. We'll take a look at how to control ICMP in this particular video, ICMP configuration command, and the lab configuration. As we go through the different videos in this video series, like Telnet and SSH, that is also going to be for management to the firewall, we'll take a look at how we allow those or enable those protocols to the firewall. So what is to traffic again? Any traffic that is destined to an interface on the firewall. It is not controlled by an ACL, it is controlled by the service running on that firewall. By default, the only service that's running on the firewall is ICMP. So that's the reason I could ping the firewall, because ICMP, the service, is running. If I try to telnet into the firewall or SSH into the firewall or try to do a web into the firewall, those services are disabled. So if the services are disabled, no traffic will be allowed to go to that firewall interface because the service is not responding. So for example, if I go back to my diagram over here, I sit on router 1 and try to telnet to 10.11.11.10, it's not going to work because the service, the the telnet service is not enabled by default. The only service that's enabled by default is your ICMP service. So this is not going to work because the telnet service is not enabled. None of the services are enabled. The only service that is enabled, as I mentioned over here, is the ICMP service. All right? And this service, when you enable or disable it, it is done on a per interface basis. So when I enable or disable ICMP, I need to specify I want to enable or disable it for a particular interface. So no other traffic by default is allowed to the firewall except for ICMP because that's the only service that's enabled. So when you do a disable or blocking of a service ICMP to the firewall, it is going to be done per interface. So I can have different policies for the outside interface or the inside interface. Is always per interface. Now, whatever I do with a service, again, will have no effect to your through traffic. The through traffic is controlled by the ACL. Through traffic is controlled by your service. So for example, if I had to do an illustration of it, my to traffic, which is this traffic, is governed by the service, whether it's running or not, whether that packet is allowed or not. Your to traffic is the green one. The other one that I'm going to draw, let's draw an orange one, that is through traffic, whether it's going to the inside or towards the DMZ. That is through traffic. ACL will affect the through traffic. Service will affect the through traffic. And they have nothing to do with each other. So if somebody wants to ping From here, he wants to ping this guy over here. I would need to allow that entry in the ACL. The service will not affect it. If I block something in the service, it has no implications on the through traffic. So something that you need to keep in mind. So they don't affect each other. So this is the last thing that we talked about. Now, how about remote management? If I want to remotely manage your firewall using SSH, Telnet, or HTTP, HTTPS, again, what do I need to do? I need to enable those services on those particular interfaces. So that's how I'm going to allow the traffic coming in into the firewall interface for those management protocols. Okay, so for example, and we're going to do that in a later video, if I wanted to allow Telnet to the inside interface, I would say Telnet, whoever is allowed to Telnet in, the IP address that's allowed to Telnet in, and the interface that I want to enable Telnet on. So this command over here is enabling Telnet on the inside interface for this particular source address. So it's per interface per source. Similarly, if I wanted to allow SSH, I would do the same thing. SSH, whatever network, whatever interface, let's say outside. So I'm enabling SSH on the outside interface. So it's a per interface type of thing. Now you might say, how about routing protocols? We did do the routing protocol. We did not enable it by doing EIGRP on the interface. Yes, we did. The only difference is when we did, let's say, EIGRP, we said router EIGRP, let's say 100. And when we use the network statement over there, let's say network statement was 192.168.3.0, basically what I'm saying is I want to enable EIGRP on this particular interface. So that's how I enable EIGRP. That's how the firewall was able to receive an EIGRP update. So any protocol that you need to traffic for, it needs to be enabled. The only one that's enabled by default is ICMP. That's why you can ping by default any interface on the firewall. Let me show you that. I can ping the outside interface from the outside router. I can ping the inside interface from the inside router. So this is the outside. I did ping that already. 3, I should be able to ping 3.10. And 4, I should be able to ping 4.10. These are all IP addresses of the ASA firewall. That's controlled by the service. All right. So that is this guy over here. Remote management is also enabled on the per interface basis. I just showed it to you. Routing protocol also sends to traffic to the firewall, the routing update, and that is enabled by the neighbor command or the network command or the neighbor command. Excuse me. That's this. Now controlling ICMP, how do I do it? By default, ICMP is the only service that is enabled on the firewall. It is enabled on all interfaces and allows all ICMP packet types to come in. So I can ping the firewall, people can ping the firewall. From the firewall, I can ping other people, send an echo and get an echo reply back, and the other people can ping my firewall using the ICMP command. So not only did I allow people to ping me on the ASA firewall, I could ping 20.2, I could ping 10.11.1, I could ping 3.3, I could ping 4.4, all the routers around me. When I'm getting pinged, the packet, the ICMP packet that's coming in is the echo packet. When I'm pinging out the packet that I'm receiving is not an echo packet, it's an echo reply packet. All right, and what's the default? All ICMP packet types are allowed. Okay. And if I want to control it, I use the ICMP command. Not permit ICMP inside an ACL, it's a command that starts with ICMP. Now, by default, everything is allowed. But let's say I put one ICMP command in. Everything else is implicitly denied. For example, right now you saw that I allowed all ICMP packets, correct? I could ping from the firewall to the routers could ping the firewall. But now if I put an ICMP command saying, hey, listen, I don't want people pinging my outside interface. So the way I would do that is I would use a command called ICMP deny any outside. What does that mean? I'm blocking any source to ping the outside. The problem with that is I'm not only denying my somebody pinging me, but my ping that went out coming back, which is the echo reply, is also denied. Okay, so it's denying anything outside. Now the other thing is you say, oh, okay, let me do this then. I'm going to allow echo reply and block the rest. So if I say ICMP permit any, I can specify the packet type echo reply outside. What am I doing? I'm basically saying I want to allow anyone, any source to send an echo reply to the outside. I don't need to say deny any outside now, because as soon as I put one line in, implicitly automatically puts a deny any on that interface for any other traffic. So the only traffic that will be allowed on the outside will be your echo reply. Okay, so that's something that also you need to keep in mind. By default, there everything is allowed, but as soon as you configure one command, everything else will be blocked. So for example, if you want to deny outside devices pinging you by using the ICMP command but allow the firewall to ping outside, you'll permit us, you will configure a permit statement allowing the echo reply. The rest of the ICMP will be denied by the implicit deny statement. That's what I was explaining to you over here. What's the syntax for the command? It starts with ICMP as a command. Action is either a permit or a deny. Source IP address or network that you want to allow. Type, echo reply. If you don't specify, it's all packet types. And which interface do you want to apply it on? So for example, if I wanted to allow that my outside interface to ping everyone else, nobody should be able to ping me, the command would be ICMP, that's the command. Action would be permit. I do want to allow the echo reply to come in. From where? Anywhere. That's a source. I could put an IP address over here if you want to. Type is echo reply. Optional parameter, if you don't put it in, it means all packet types. And the interface. In my case, the interface that I want to control it is the outside interface. So that's the way a command would look. But then again, if I put one command in, the second command, the implicit deny any, will take care of the rest of the ICMP traffic. It's going to block everything else. So based on this, we'll do a lab over here real quick. This is the same topology now. The requirement that I have, I want to allow R2 20.2 should be able to ping the firewall outside interface. Let's do this in Notepad again. We'll clear this up and I'll put the command in. So my first requirement over here, so we can see the requirement as well, is R2 should be able to ping the outside interface. ICMP is the command. Permit should be able to ping the outside interface. So the source is host 192.1.20.2 should be able to ping, which is echo, the outside interface. Second one, the 199.110 network should be able to ping the outside interface. So permit 199.110, the mask, echo, outside. The third one is firewall should be able to ping any outside interface. See, based on this, I would have an implicit deny any. So my echo replies will be blocked. So I'll say ICMP permit any source should be able to be able to send me the echo reply on the outside. So this would allow my echo reply to come back. The ICMP should be blocked for all other traffic on the outside interface. So that I've taken care of. The first four bullets are done. The fifth one is firewall should be able to ping devices to on DMZ4. ICMP should be blocked for all other traffic on the DMZ4 interface. So they also want to do what? Allow the ping on the DMZ interface. So I'll say ICMP permit any echo reply DMZ4. I don't need to worry about the rest of it because as soon as I put one line for this DMZ4, everything else is blocked. ICMP should be blocked for all of the traffic on DMZ4 interface. That's two traffic. So let's go ahead and take a look at it, see if it works. I copy it, go to my firewall over here, paste it, show run ICMP, shows you the commands, the 3 commands for the outside and 1 command for the DMZ. So now to verify it, what I'll do is, while I'll go to this guy over here, R2 should be able to ping the outside interface. Let's check. I am still able to ping this guy. That is done. 199 should be able to ping the outside interface. Let's try that. Ping 192.20.10. Source is 199.111. Works. If, as you guys can see, I have another interface over here, 200. If I try to ping the same interface with a source of 200, it will not work. That's blocked. So this one is able to ping, the rest is blocked. The firewall should be able to ping any outside interface. So on the firewall though, although 200 cannot ping it, but on the firewall I should be able to ping the 200 or the 199. So I can get an echo reply for any one of them. The last one was the DMZ4 interface. So if I go to the ASA, should be able to ping 4.4, no problems. But 4 should not be able to see. It was pinging 4.10 before, now it won't be able to. So that's how you control ICMP to the firewall. And as you guys can see, it's per interface. I had no effect on the inside or the DMZ3 interface. So similarly, we'll go in and take a look at the remote management and enable different protocols for remote management, because when you do remote management, again, you're telnetting in or SSHing into the firewall, to the firewall. That is also considered to be traffic destined to the firewall. All right. Hope you guys enjoy the video. See you guys in the next video.